Good morning. I've been doing a lot of substitution lately, so I'm going to mix it up and do elimination. Remember, when you're solving a system, you can do it any way. You can do substitution, elimination, or graphing. It doesn't matter. Remember, if you're doing elimination, it's kind of like a TV show where they vote people off, right? You want to get rid of something. And remember, when you get rid of something, typically it usually makes them feel kind of bad. So that means one of them is going to be negative because he's feeling bad. He's getting rid of. I don't see any negatives here. So it's going to be very hard to get elimination. You always want to get rid of the bad attitude, right? So I have to make one of these negative. I'm going to check the numbers in front of my variables to see if I have anything that naturally cancels out before I do too much. So I see that the ones and the ones are the same. So I just need one of them to be negative. So that means I can take this whole thing and multiply it by -1. That way I have one of my variables giving me bad attitudes so I can eliminate them. I always like to write stuff horizontally, because it helps it make more sense in my brain. So I'm just going to copy this equation over here. And then I'm going to go very slowly. So I'm going to do -1 times 1. -1 times 1 again. Notice that became a -1y now. This sign, it does mean addition, but it also just means positive. It's both an operator and an indicator. And then don't forget to multiply my negative times 100. Notice how slow I went there. I wanted to make sure I did everything correctly. You can even take an extra step and write -1 times 1x plus 1y times -1 equals 100 times -1. If you want to write that extra step, do what helps you. Now it's set up for elimination. I know it's set up for elimination because right here I have a great example of what's called our additive inverse property. So our additive inverse property means that when you add opposites, you get 0. Simple as that. So when you add opposites, you get 0. Okay, I am adding these two equations, so make sure you put your plus sign, because sometimes it's easy to forget what we're doing, especially in a high-stress environment like a test. -1 plus 2 is +1. And I want to make sure I did that right, so I'm going to type it in my calculator. It never hurts to use a calculator. Alrighty, so that's 1x. -1y plus 1y is 0, based on that additive inverse property. And the last one, and I'm going to type it again, -100 plus 135 equals 35. Sometimes typing in is an extra step, but I know I did it right. I'm going to simplify this side. Anything plus 0 is itself. So 1x plus 0 is 1x. So here I get x equals 35. So I have my first value. And again, I'm going to go straight down to my solution. And I'm going to go ahead and write that part so I don't forget. It's kind of funny in elimination, because after you do the elimination method, you actually have to do substitution. So there's no escaping substitution. I'm just going to do my first equation. And one of the mistakes people do is they accidentally write the equation they transformed, not the equation they were given. So the first equation is x plus y equals 100. I'm going to keep that equation. I'm not going to write the negative version. I know x is 35 because that's what I solved for. I'm going to put 35 in that x spot. Now remember, when we're solving equations, we want to distribute and then combine like terms. We don't have to distribute here, so we're just going to go straight to combine like terms. When you move across the barrier, you do your opposite. So I'm going to move my 35 this way, and it's going to give me 100 minus 35. Alright, come on, calculator. I know you called it calculator, but we're going to calc you now. Alright, 65. Okay, so my coordinate point is 35, 65. And remember, you can always check your answer by doing a different method. Have a great day, guys.